Okay, in this lesson, we're going to be finding the trig functions for any angle. Now, last lesson says in the previous lesson, you found the trig functions for positive acute angles like the sine of 30, cosine of 45, and so on and so forth. However, what about all the other angles? What if we're in second, third, fourth quadrant? What about those angles? We will now find trig functions for any angle. So let's let theta be an angle in standard position. A reminder that standard position means that your initial side lies along the positive x-axis and then you're rotating from there. So here we have this angle theta is in the second quadrant. What about it? So let theta be an angle in standard position and point P be right here, and that'd be point P is at xy, be a point on the terminal side. That's on that side of theta. The distance from P to the origin, just a reminder that the distance from here to here can be found with this formula. The distance, first off, from here to here, that's your x value. The distance from here up to here, that was your y value. So if you look, it's created a little right triangle, and we can use Pythagorean theorem to where x squared plus y squared is equal to r squared. And that should look familiar to you. That should look like something else that we've dealt with in the past, and we'll talk more about that in just a second, or in a previous lesson, or the next few lessons. So if that be the case, then if you want to find the sine of this angle, the sine of the angle theta can be found by doing opposite over hypotenuse, which would be y over r. The cosine of theta would be x over r. The tangent of theta would be opposite over adjacent, which would be y over x. The cosecant would be the reciprocal of sine, so that'd be r over y. Secant's the reciprocal of cosine, which would be r over x. Then cotangent would be x over y. So let's try a problem just to show you. So if point P is located at 9, negative 12 is a point on the terminal side of theta in standard form. Find the exact values of the trig function of theta. So let's take and kind of sketch out a little graph. So here's my xy axis. So 9, 12, 9, negative 12 will be located somewhere down in here. So here is my theta, or my angle, that's got the point P on it. Here's my initial side. So I got my initial and terminal side. So here is my angle. So what we can actually do, instead of drawing this, let's draw a little right triangle right here. And you could actually say, okay, we went over 9, we went down 12. Now, one thing you do have to be careful of is the signs here, whether it's going to be positive or whether it's going to be negative. Now, if you use the positive 9 and negative 12, the signs will take care of themselves. You can do a squared plus b squared equals c squared. You do Pythagorean theorem, and you're going to find out that your r is 15. So my x value is 9, my y value is a negative 12, and my r value is 15. And again, later on, we'll talk about, as far as positives and negatives, what's supposed to be positive, sine, cosine, and tangent, where. So now let's go through and let's find all the different values. My sine value, which is opposite over hypotenuse, is going to be my y over my r. So that would be a negative 12 over 15. My cosecant would be the reciprocal, negative 15 over 12. My cosine value, if you look back up here, is my x over r, which would be 9 over 15. And I should have reduced those. That would be negative 4/5 and negative 5/4. 9 over 15 was going to be 3/5. My secant, therefore, would be 5/3. My tangent is going to be opposite over adjacent, which is my y value over my x value, which is negative 12/9, which reduces to negative 4/3. So therefore, my cotangent is negative 3/4. Number 2, doing the exact same thing, we have a point located at negative 6, negative 2. I'm going to kind of sketch it out. Negative 6, negative 2 will be somewhere right in here. So there is my angle. So I have negative 6 is my x, negative 2 is my y. I've created a little right triangle. You can do x squared plus y squared equals r squared, the Pythagorean theorem. Gives you 36 plus 4 equals r squared. So 40 is r squared. So r is the square root of 40, which you can split into root 4 times root 10. So r would be 2 root 10. So my x was negative 6, my y was negative 2, and my r is 2 root 10. So there's all my values. Sine is opposite over hypotenuse, which would be my y value over my r value 2 root 10. So that's going to be 2's cancel. That'd be negative 1 over root 10. Rationalize it is negative root 10 over 10. We can flip it. However, again, it's the best to flip this instead. That'd be root 10 over 1, which would just be negative root 10. My cosine value is adjacent over hypotenuse, which would be x over r, which would be negative 6 over 2 root 10. I lost my negative. Let me put it right there. Reduce it. That'd be a 3 and a 1. Rationalize by multiplying top and bottom by root 10 would be negative 3 root 10 over 10. It's best to flip here to find the secant. That'd be negative root 10 over 3. And finally, my tangent would be my y over x, which is negative 2 over negative 6, which is a positive 1/3. So therefore, cotangent would be positive 3. Okay, next up it says, depending on the location of the terminal side of the angle, trigonometric functions may be positive, may be negative, as you could see in the last few examples. Using your knowledge of trig function values, identify the functions that are positive in each quadrant. Now what I've done here, just a reminder that sine, cosine, and tangent, there's the definitions of each. And if we were to do, now r, my radius value, is always going to be positive. So if I do sine is equal to y over r, and I go through that, that means that my sine value, let's do it like this. My sine value in the first quadrant is going to be my y value over my r value, which will be a positive. In the second quadrant, it'll be my y value over r, which is positive. In the third quadrant, it's going to be my y value over my r, which is a negative, and the same in the fourth quadrant. And if I continue doing that on, I can kind of see a little pattern develop, and here's what I get. And I can use that to tell what's positive in which quadrants. Now notice in quadrant 1, all three, sine, cosine, and tangent are all three positive. I'm going to put all. In the second quadrant, only my sine value is positive. In the third quadrant, only my tangent value is positive. And in the fourth quadrant, only my cosine value is positive. Now, there's a good way for remembering this, and this is how I remember it. I remember it as all students take calculus. Starting with the first quadrant and rotating around to your fourth quadrant, all students take calculus. Everything is positive. S stands for sine, T stands for tangent, C stands for cosine. All is positive. Sine, tangent, cosine. Tells you what is positive where. Now you could flip-flop that. Since sine is positive, then I know that cosecant would also be positive. Since tangent is positive here, that means cotangent would also be positive. And since cosine is positive, then also secant would be positive. So again, remember the phrase, all students take calculus, rotate it counterclockwise, and this is the reason that that does work out. So number 3, if cosine is greater than 0, so that means that cosine is positive. That means, first off, let me erase some of this extra. Since cosine is positive, that means that we're either here or we're here. That's where cosine is positive. Everything's positive here and cosine's positive here. Which quadrants could the terminal side of theta lie? So if cosine is positive, we could either be in quadrant 1 or we could be in quadrant 4. One or the other, 1 or 4. And this is, let's go ahead and put our Roman numerals, 1, 2, 3, and 4. Number 4 says if tangent is less than 0, that means tangent is negative. Where is tangent negative? Okay, tangent is positive here and tangent is positive here. So where is tangent less than 0? That would be quadrants 2 and quadrant 4. Where could it lie? If secant is less than 0, and again, I have to do this. If secant is less than 0, that means cosine is less than 0, because secant and cosine are reciprocals. So where would that lie? Where is cosine negative? That's what less than 0 means. Cosine is positive here and here, so cosine will be negative here and here. So that'd be either quadrant 2 or quadrant 3. And finally, number 6, if sine is less than 0, so that means sine is negative. Let's stop there for a second. Sine is positive here and here. Sine is negative here and here. So sine is negative and cotangent is positive. Now, if cotangent is positive, that means that tangent is positive. Which quadrant are we in? So sine is negative, so that means we're either here or here. However, tangent is positive, so that means we have to be here. We would only be able to be in quadrant 3. Okay, next up, use the given information to find the exact values of the remaining trig functions of theta. So we've already done this before. However, before we actually said, okay, sine is 8 over 17 and all that. We did it a little bit different. Now it's a little bit easier because what we can now do is we can say, okay, since sine is positive and tangent is less than 0, that means tangent is negative. Let me draw my chart over here. Since sine is positive, that means that we either have to be here or here. However, tangent is negative, and since everything's positive here, that means we are in the second quadrant on this problem. So the only thing that's going to be positive is sine. So sine is positive, tangent's negative, cosine is negative. So what I would do is go ahead and take care of all the positives and negatives. So sine is positive, and that's the only thing that's positive. So cosine's negative and tangent's negative. Cosecant would be positive because sine is positive, and secant and cotangent would be negative because cosine and tangent are negative. So we've taken care of that. Now, how do we find the rest? Here's theta. Just draw your little right triangle. Since the sine is opposite over hypotenuse, label it. Opposite over hypotenuse is 8 and 17. Pythagorean theorem, a squared plus b squared equals c squared will give you the value of b. 64 plus b squared is equal to, I believe, 289. Work that out and you get a b value of 15. So now you've got your triangle labeled. Now you can finish your chart. Your cosine value would be adjacent over hypotenuse, which is 15 over 17, which means your secant would be 17 over 15. Your tangent value would be opposite over adjacent, which is 8 over 15, and it's negative. So therefore, cotangent would be negative 15 over 8. Your cosecant is the reciprocal of sine. So since sine is 8 over 17, then cosecant would be 17 over 8. That's it. Next up, it says cotangent is negative 4. And again, I like to deal with tangent. So as soon as they give me cotangent, I'll flip it to give myself the tangent. So therefore, the tangent, I can go ahead and put it in my chart. The tangent is negative 1/4. And it says the secant is greater than 0. So since secant is greater than 0, let's flip that. That means that the cosine is greater than 0. Because again, I don't like working with secants and cotangents and all that. I like sine, cosine, and tangent. So where is cosine positive? That's either here or here. However, where it also has to be a place where tangent is negative. Tangent is positive here, so we have to be in the fourth quadrant. So the positives and negatives there tells you what quadrant you're in. Since we're in the fourth quadrant, we can go ahead and label everything. Cosine will be positive, sine will be negative. The only one of the three originals that are positive in the fourth quadrant is cosine. So therefore, since sine is negative, cosecant's negative. Since cosine is positive, then secant is positive, and we already know that cotangent is negative because we're right here. So now let's go ahead and let's draw ourselves a right triangle. Let's label one of the angles theta. And I know that tangent is negative 1/4. Now I don't have to worry about the positives and negatives anymore. All I have to worry about is the 1 and 4. Tangent is opposite over adjacent. Opposite adjacent would be 1 and 4. Pythagorean theorem gives you the square root of 17 for your missing side. Now we've got all of our side lengths. The sine would be opposite over hypotenuse, which would be 1 over root 17. And again, it is negative because we're in the fourth quadrant. Rationalize that by multiplying top and bottom by root 17 gives me negative root 17 over 17. The cosecant would be the reciprocal, which would be root 17 over 1. Flip this. Next up, let's do the cosine. That would be adjacent over hypotenuse, which is a 4 over root 17. When you rationalize it by multiplying top and bottom by root 17, and you don't have to put the plus sign. We know that it's positive if that's not there. To find the secant, we are going to flip that, so that'd be a root 17 over 4. And I believe that's all the different pieces. You could find tangent. Again, we're given tangent, but the tangent would be opposite over adjacent, which is the 1 and 4. Next up, cosecant. So let's go ahead and flip that. If the cosecant is negative root 5 over 2, then our sine will be negative 2 over root 5. We can rationalize that by multiplying top and bottom by root 5. It would be negative 2 root 5 over 5. So therefore, my sine value is negative. My cosine value is also, it says right here, negative. That's what less than 0 means. So where is sine negative and cosine negative? Well, let's start out with where is sine negative. I know that sine is positive here and here, so therefore sine is negative here and here. However, cosine also has to be negative. Well, cosine is positive here, so we must be in the third quadrant. Now, the only thing that's going to be positive of the original three is going to be tangent. So tangent is positive. Sine and cosine are both negative. So therefore, secant, since cosine is negative, secant is negative. Since tangent is positive, cotangent is positive. So we've already got our sine value, which was negative 2 root 5 over 5. We just found it a while ago. So therefore, now let's find the other ones. Let's draw ourselves a little right triangle. Here's my angle. I know that sine is opposite over hypotenuse. So the opposite would be 2 root 5. The hypotenuse would be 5. Perform the Pythagorean theorem. Now, if you don't remember how to square this, square each piece. Square the 2, square the square root of 5 gives you a 4 and a 5. So that'd be 20 plus b squared is equal to 25. So work that out and you get b is going to be root 5. So now we can finish up. Our cosine now would be adjacent over hypotenuse, which would be root 5 over 5. The secant would be the flip of that, which would be 5 over root 5. Rationalize by multiplying top and bottom by root 5. And that's going to give you 5 root 5 over 5, which is just going to be negative root 5. Our tangent value is going to be opposite over adjacent. Now this is a shortcut here. Opposite over adjacent will be 2 root 5 over root 5. You can cancel those roots out, so your tangent value is going to be just 2. So the cotangent value will be 1/2.